Question number 1. Find the third degree Taylor polynomial for f of x equals the square root of x minus 2 centered at 4. Third degree means we need to find the third derivative. So I'm going to start by rewriting the original function as x minus 2 to the 1/2. The first derivative will give me 1/2 x minus 2 to the negative 1/2. The second derivative will give me negative 1/4 x minus 2 to the negative 3/2. And the third derivative gives me 3/8 x minus 2 to the negative 5/2. And we're centered at 4, so our next step is to plug in 4. Well, if I plug in 4 to the original, 4 minus 2 is 2, so I get the square root of 2. The next one, I plug in 4, 4 minus 2 is 2, so I end up getting 1 over 2 times the square root of 2. The next one, we have negative 1/4, and that will be times, 1 over the square root of 8, I believe. So that will reduce to negative 1 over 8 square root of 2. And then the last one will be 3/8 times 1 over the square root of 32. And the reason I'm getting this is 4 minus 2 is 2, and then the negative sends the exponent to the bottom, and then 2 to the 5th is 32, and then the square root is that 1/2 part. So let's see, I believe that will give us 3 over 32 square root of 2. If you want to do the decimal approximations on that, you can. That's no problem. In fact, I will put those up there for you right now. You can see there what the decimal approximations are. I would accept it either way. I'd say it's preferred to use the ones that aren't decimal approximations, but I will accept either one. So now that we have those coefficients, we need to plug it into our general equation. So I'm going to move number 2 out of the way here. My general equation for a Taylor polynomial is going to look like f of c plus f prime of c times x minus c f double prime of c over 2 factorial x minus c squared plus f triple prime of c over 3 factorial times x minus c cubed. So now we just plug in the values we found for f of c, f prime of c, f double prime of c, and so on. And our center's at 4, so we're plugging in 4 for the c. We end up with a square root of 2 plus 1 over 2 square root of 2 times x minus 4 plus, or actually be minus because of the negative, so negative 1 over 8 square root of 2 over 2 factorial x minus 4 squared plus, or actually minus because of the negative. Oh, no, that should be positive. I'm sorry. That should be positive. So let's see, that should be positive. 3 over 32 square root of 2 all over 3 factorial times x minus 4 cubed. Okay, now that can be simplified further either by just simplifying the fractions or doing the decimal approximation. I'll put both of those up there so you can decide if it matches what you have. Okay, so all three of these are equivalent forms. These three right here are all equivalent forms of the same thing. So if you have any one of those, that would be acceptable. Honestly, the top two are probably the better ways, but all three of those would be acceptable forms of the answer. Now, number 2 is a little bit tricky in the way it's worded. It says, use your answer from number 1 to approximate the square root of 2.15. So what you'd be tempted to do is plug 2.15 in for x. But if you look back at the original problem, it was the square root of x minus 2. So try to think this through with me. If we have the square root of x minus 2, and I plug in, let me try that again, square root of x minus 2. If I plug in 2.15 for x, then what I'm actually finding is 0.15, square root of 0.15. That's not what they asked for. So that's not what we want to do. We need to figure out what x value would make this the square root of 2.15. Sorry, my handwriting's having trouble here. There we go. So the x that you would need to plug in order to make this 2.15 would actually be 4.15. So 4.15 minus 2 equals the square root of 2.15. So in order to approximate the square root of 2.15, you would have to plug in 4.15 for x. And it usually is going to be asking you to plug in something close to your center. So it makes more sense that they're asking us to plug in 4.15 than 2.15. But to do that, you simply need to plug 4.15 into your answer that you got for number 1. So I already have this plugged in my calculator under y equals. So I plugged that whole thing in, y equals. Now I can just go to my table and plug in 4.15. You could ignore all the other numbers. And I get 1.466 is my answer. So the answer would be 1.466. Now to see how good our Taylor polynomial was, let's compare that. You don't have to do this part, this is just for illustration. Let's compare that to the actual value of square root of 2.15. And it's pretty darn close. So that means we have a good Taylor approximation using that polynomial. Number 3, find the radius of convergence for this series. What is the center of the series? Okay, well, first of all, to find the center, you need to figure out what value of x you would plug in to make the whole thing 0. So the center of this series is at 4. Another way to look at it is what's being subtracted from x. That will be your center. If nothing's being subtracted from x, then it'll just be 0. Okay, now to find the radius of convergence, we have to perform the ratio test. So we do the limit as n approaches infinity. We put the original on the bottom. On top, I add 1 to all the n's. Notice I didn't bother with the negative 1 to the n. That's still included in the original, but for the ratio test, I don't need to include it because we're doing the absolute value. So the absolute value wipes out that negative 1 to the n from doing anything. So then I add 1 to all the n's. And then I have a fraction over a fraction, so I'll need to multiply by the reciprocal. Okay, now it's time to simplify. The 5's will all cancel out except for one of them on the bottom, because there's one more on the bottom than there's on top. The x minus 4's will all cancel except for one of them on top. And the n's we cannot cancel out. So we're left on top with x minus 4 times n cubed, and on the bottom we're left with just n plus 1 cubed. Times 5 actually, excuse me. We still have this 5 left over right here. Now as we take the limit as n goes to infinity, still have absolute value. As we take the limit as n goes to infinity, the n's have the same powers. We have n cubed up here, we also have n cubed right here. When the powers are the same, the answer is going to be our coefficient. So I'm going to move this down so I have a little more room. My coefficient on top is x minus 4. My coefficient on the bottom is 5. So I get the absolute value of x minus 4 over 5 is the answer for my limit. Now what the ratio test claims is that if your limit is less than 1, you converge. So we need to figure out when this is less than 1. Remember, you can simplify within absolute value by multiplying or dividing. So I can multiply both sides by 5 here and get rid of that, and I see absolute value of x minus 4 is less than 5. And that's as much simplifying as I can do, so this is my radius of convergence. That means I can go up 5 or down 5 from my center and still converge. Number 4 then is asking about the interval of convergence. Okay, well like I said, our center is at 4. Again, that's the x value that would make the entire function 0. So I'm going to write on a number line here. Our center is at 4. And since our radius is 5, we can go up 5 to 9, or we can go down 5 to negative 1. So I know right now my answer is going to be negative 1 to 9. It's just a question of whether I'm going to do parentheses or brackets around each one. To figure that out, I need to go back to the original and plug in -1 for x and then plug in 9 for x. So let's give ourselves a little more room here. And back in the original, we had -1 to the n times x minus 4 to the n over n cubed times 5 to the n. I'll double check that that's correct. Yes. So now if I plug in -1 for x, if I plug -1 in for x right here, -1 minus 4 would give me -5. So I plug -1 in for x in the original, gives me -5. -1 times -5 gives you +5. Then the 5 to the n's cancel out, and you're left with 1 over n cubed. So simplifying leaves me with a p-series 1 over n cubed. And this p-series converges because the power is greater than 1. So I put a bracket around -1. Now I do the same thing, plugging in +9. 9 minus 4 is +5 to the n over n cubed times 5 to the n. The 5 to the n's cancel again, but this time, instead of a p-series, I'm left with an alternating series. Now the alternating series, to determine if they converge or not, you have to take the limit as n goes to infinity without the alternating part. And if you get 0, which we do here, then the series, the original one, converges. So since the series converges, we also include 9, and we use a bracket. So the interval of convergence would be -1 to +9, both inclusive. Alright, 5. Find the power series for f of x equals 5 over 2x plus 3, centered at -3. This is the geometric power series where we need to do 4 steps. First step, the denominator needs to be number first, variable second. So I reverse the order, make 3 come first, 2x come second. Step 2, I need a minus sign in between them instead of a plus sign. So I rewrite this as 3 minus -2x. My third step is to fix the center. When I look just at this portion in parentheses, only the part I've got marked in red, when I look just at that portion, I need, when I plug in my center, to get 0. Well, if I plug -3 in for x right now, I would get -2 times -3, which is +6. I need to get 0. So the way to change that is to subtract 6 from both sides. So I change it to -2x minus 6. But I can't just change something without balancing it out, so since I subtracted 6 from the parentheses, I also have to subtract 6 from this 3. Now if I plug in my center, I do get 0 in this one portion right here. It's just the parentheses you're worried about, getting 0. And then, the last and final step, you need this number to be a 1. To accomplish that, you divide every single piece by -3. So on top I get -5/3 over 1 minus -2x minus 6 over -3. Now I'm finally in the geometric form a over 1 minus r, and I can rewrite this as a power series where I put a in front, and I have r raised to the n. You're welcome to leave your answer like that. However, since everything inside the parentheses is negative, you can actually change them all back to positive and write it this way as well. Either one of those answers would be accepted. Number 6, find the first 4 terms of the Taylor series for f of x equals 4e to the x minus 2 cubed. Whenever they ask for a Taylor series, you need to think to the 4 that I made you memorize. In this case, our base function is e, so e to the x. And it just asks for the first 4 terms. Just for practice, I am going to go ahead and write the general term. But this question just asks for the first 4 terms. First thing you should always do is any substituting. So they have replaced the x with x minus 2 cubed. So everywhere that I see an x, you need to replace it with x minus 2 cubed. Alright, now that can be simplified. Cubed squared gives you to the 6th. Cubed cubed gives you to the 9th. And 3 times n would make it raised to the 3n. Okay, so we have successfully put it in this form, e to the x minus 2 cubed. The last thing it does is multiply the whole function by 4. So I multiply every single piece I see by 4, making my final answer look something like this. Alright, that would be acceptable. If you want to reduce these two terms, you can. So this would also be one other way you could write it. 4 over 2 factorial is just 2. 4 over 3 factorial is 2/3. And then there's nothing really more we can do to simplify that. And I'm out of room for the plus dot dot dot, but you should have one after that. Alright, that's number 6. Last one, finally. Evaluate the first 4 terms of the Taylor series. Again, you see series, you need to think the 4 you've memorized of that. Okay, so sine of x squared over x. We start with sine of x as our base point. Sine of x is equal to x minus x cubed over 3 factorial plus x to the 5th over 5 factorial minus x to the 7th over 7 factorial. And for these where you're actually evaluating, there's really no reason to worry about the general term, so I'm not going to. So we can just stop there with the first 4 terms. Now the next transformation that needs to happen is always the substitution. So x on the inside is now replaced with x squared. So every x I see gets replaced by x squared. Now some of you may be able to do some of this simplifying in one step instead of writing it in 2 steps like I am, and that's completely fine if you can. This will become x squared minus x to the 6th over 3 factorial plus x to the 10th over 5 factorial minus x to the 14th over 7 factorial. And then it asks us to divide everything by x. So we get sine of x squared over x. So that just reduces everything by 1 power. Okay, so we've made the function look like it needs to. Sine of x squared over x, which is what they have right here. The next step is to take the integral of that. So we take the antiderivative of this function. So add 1 to the exponent, divide by that number. Add 1 to the exponent, divide by that number. Add 1 to the exponent, divide by that number. Add 1 to the exponent, divide by that number. And we're doing this all from 0 to pi. Now if you notice, plugging in 0 is just going to make everything go to 0, so the only thing we have to do is plug in the pi. So I need to plug in pi, and that will give me my approximation. So 1/2 times pi squared is the first term, minus pi to the 6th divided by parentheses 6 times 3 factorial plus pi to the 10th over 10 times 5 factorial minus pi to the 14th over 14 times 7 factorial. that gives you negative 73.013 if we're rounding. So negative 73.013.